We will now show you the general maintenance and repair procedures on the JSE1 torque limiter. This is used on the Model 1100 tub grinder, and the JSE2 used on the Model 1200 and larger models. You can see here the assortment of tools needed to do the necessary repair work. The tools include an Allen wrench, spanner wrench for each model, a depth micrometer, a dial indicator, and a simple puller to pull the detent pockets. Our main objective for today is to discuss the JSE2 torque limiter, which will now be used on all our tub grinder models. Now the only difference between the two is basically the size. The inner pieces are larger, but they perform the same functions. In our first procedure, we will show you how to extract the safety elements from the JSE2. Then we will separate the base units. We're about to show you the removal procedure for the safety element. Now on the older units, if there are no numbers shown here indicating where this was at, you need to take a prick punch or something and mark the unit so you can match up the holes. Take note of this, especially when you're just inspecting the unit. You do this to keep the shim pack, the ball, and the detent, everything together, because it is already preloaded, and if things are correct, you can go back into the same hole. To remove the unit, unscrew these 4 screws. As you begin to pull out the safety unit, try to keep the shim and bushing together. Remember, keep the safety element parts together. To pull the 2 halves of this unit apart, after the safety elements are out, remove all the 6 cap screws. After the last cap screw is removed, check to see that it is marked on the shaft. So when reassembling, the same bolts will go back into the same holes into the hub. Now, to remove the hub, set the outer housing on something to prop it up. This will allow you to tap on the inner part without any interference. Now that both halves have been separated, we're going to remove the stub shaft out of the center. We recommend you use a lead hammer, piece of brass, or a plastic hammer to make it easier. Set the unit up on something and drive the stub shaft out. As you can see, one bearing came out, the other is still in. Check these bearings as a part of your regular yearly maintenance. If everything looks okay, then you can begin to reassemble. When you grease the flange on your drive shaft, the grease is inserted here. The flange is bolted on here. Additional grease added here is forced between the bearings. Now here's a close-up of the grease port. As we stated before, the flange bolts on here. There's a grease zert out here on the flange. The grease travels through here in between the bearings. Notice the high spot in here. After you get the bearings in with the stub shaft and the bolts are tightened down, it holds it all together. When this unit breaks loose and the elements pop out, this half stops and this half keeps turning as the clutch shaft is bolted to the back side and the drive shaft is bolted here. So it has to run on these bearings on the shaft. That's why every time that this is released or popped loose, make sure that you keep grease on the rollers and the bearings. Now normally these go in fairly easy. Just tap the bearing back into place with a lead hammer until flush. Remember, this has to go back in on the flange end, the drive shaft end. Notice one side of the bearing has a grease seal, the other side doesn't. When assembled, be sure to keep the grease seal side out. After the bearing is back in place, don't forget to put this spacer ring back on. So when you draw it up tight, the spacer ring touches the flat surface and not just the stub shaft. Now, before you put this on, you may notice some grooves on this inner surface. This is possibly caused by pieces of the detent pocket that have broken off. Don't be alarmed by this. This will not affect the operation of the torque limiter. Now that you have the torque limiter apart, check these holes that the detent fits into to make sure there are no edges on them. If they do, clean them up with a die grinder or file to remove the edges. Now you're ready to put the unit back together. Be sure to find the marks that were made earlier. This will allow you to line up the bolt holes properly. We're now ready to set this back in place. When the two housings are back together, now's a good time to clean up the bolts and remove the old Loctite. We'll use some Loctite solvent or brake clean will do. After cleaning, we apply a stud grade Loctite, and 1 drop should be efficient. We'll put the bolts back in now. By the way, these bolts will be torqued to 33 foot-pounds. Again, double check your marks to make sure they're lined up. As I mentioned, the torque wrench is set to 33 foot-pounds. Be sure to alternate bolts to get an even torque. To pull a detent pocket, to check it or turn it, you'll need either a bolt and slide hammer or just a simple puller like this one. This is illustrated on page 15 in your operator manual. I prefer the slide hammer for our demonstration here. After removing the bolt that holds the detent pocket in position, the inside of the detent is threaded, so you can screw a proper size bolt in it or the puller. Then use the slide hammer to remove the detent pocket. We'll now show you a close-up of the detent pocket. There's a threaded hole in the bottom. This area is where you'll get wear. Here's a detent pocket out of the JSC1. And as you can see, it's worn and broke off on the back side. Now this can be turned a quarter turn and pressed back in, and you're back in business. As we stated earlier, the same principle applies to both the JSE 1 and 2. The only difference is size. This is the element, the bolts, and the detent and ball of the JSE 1, and these are from the JSE 2. The JSE 2 is for larger horsepower. As an example, we're going to 650 horsepower with this, while we stop at 525 horsepower on the JSE 1. As of January this year, we are using the JSE 2 on both the 1100 and 1200 model tub grinders. After inspecting the detent pocket and the bottom of the hole where it fits to make sure there's no obstructions or wear, you can then simply drop it back into place. Make sure it fits tightly. Then take a proper size punch to drive the detent pocket back down. Now that the detent pocket is back in the base, clean the bolt of old Loctite. Then use a drop of stud grade and insert the bolt. This bolt must be torqued to the correct specifications according to the manual, which in this case is 33 foot-pounds. Now we will show you how to disassemble a JSE 2 safety element. Notice the plunger bushing here, which holds the detent ball. When removed, this exposes the spanner nut in here. On the side is a set screw, and behind that is an aluminum plug designed not to damage the threads on the spanner nut. We'll now loosen that and then put it in the vise. We are now ready to remove the spanner nut using this wrench. One could use a couple small punches and a screwdriver to do the job. We simply screw it loose and remove the spanner nut. This allows us to remove all the parts inside the safety element. Be careful not to drop any of the small ball bearings down inside the safety element. At this stage, you can start cleaning the elements and inspecting the parts before reassembly. Now shown are all the component parts to the JSE 2 safety element. As you disassemble the safety element, be sure to count all the parts to avoid confusion later when reassembling. These are the small 10mm plunger balls. This is the aluminum locking plug used to lock the spanner nut. This is the plunger, the outer thrust ring, the inner thrust ring, the disc spring washers, the adjusting spanner nut, the plunger, and the housing. Before assembly, you should put a film of grease on these parts. But first, let's look at the wear marks on the outer thrust ring. Here's where the wear has occurred. Now, the main wear components of the unit are the outer thrust ring, the inner thrust ring, the plunger, and the ball bearing. Once these wear grooves get too deep, you won't be able to hold your pressure setting. At that point, you would have to replace these items. Here is the wear marks on the plunger. If these become excessive, you'll have to replace the plunger. Now we're ready for assembly. And first we will coat the parts with a moly base grease. The outer thrust ring goes in first, with the bevel part up. This is quite a tight tolerance in here, so you may have to tap it into place. We'll now coat the outer thrust ring inside with the moly base grease. Next, insert the plunger. And set the balls around the plunger. It may look like you're short a couple of ball bearings, but the extra space is needed so when this releases, the plunger can move like it's supposed to. Next, install the inner thrust washer, making sure the bevel side is down. After the inner thrust washer is installed, we next install the disc spring washers. You can see here the concave shape of these washers. Before installing, we'll apply a thin coat of grease on them. Now these washers will receive grease after assembly through the grease zert on the end of the plunger. Take note, these washers must go in a certain way, with the outside of the disc spring washer making contact with the inner thrust washer inside. Now the next washer will alternate, so the inside part makes contact with the other washer. After they are all installed, these washers together will form a type of spring. Again, remember to alternate the disc spring washers. When the last one is installed, make sure the outside of the washer is up to make contact with the back of the adjusting spanner nut. And we can now install the adjusting spanner nut. After all the component parts have been installed, we now want to find zero spring compression prior to setting the element. Now this can be done in two ways. Here we're using a dial indicator. When turning the adjusting spanner nut, the dial will move. And when the needle stops, we should be at zero spring compression. And right there is at zero spring compression. You can also determine zero spring compression by turning the adjusting spanner nut like this until you reach a point where it becomes tight. This accomplishes zero spring compression like the dial indicator did. Now that we've found zero spring compression, we want to scribe the spanner nut and housing. Next, take a depth micrometer and take a reading to see where we're at. Place the micrometer on the scribe point for each reading. Set it on the base and hold it firmly and tighten till it stops. And write down the reading. On this JSE2 unit, we'll reduce it from 80 to 90 thousandths We know we're at 0 spring compression, so now we take a spanner wrench and tighten 90 thousandths, which by the way is maximum for the 650 horsepower engine. And we'll continue to take readings until we reach 90 thousandths. Tighten some more. And check it. Using the scribe. Check it again. There we have 90 thousandths. Now we can take this aluminum locking plug and insert it in this hole. Then insert the set screw and begin to tighten down. When you replace the bushing, the plunger may not center itself in there. If that's the case, check where it's off center and tap it into alignment until the bushing slides into place. Now you can see it moves freely. Now that the unit is all inspected with new parts replaced where needed, it's time to put it back into the torque limiter. Make sure the bushing is on, ball bearing installed, and don't put any grease on just yet. We first want to determine what the distance is between the element and the base. So we'll take a feeler gauge and check the distance here. Looks like we have 31 thousandths. So now we can make a shim pack. We want to make sure our shim is from 6 to 12 thousandths less than our gap. That's so when we draw this down, it actually preloads the ball in the detent. We should point out that these shims are peelable shim packs, and you can peel off 2 thousandths at a time. So we'll make this shim pack 8 to 12 thousandths less than our 31 thousandths gap measurement. Now that we have our shim pack, we'll take this element back out and grease the ball. Again, use a moly base grease. Reinsert the bushing, then put some grease on this spanner adjuster nut. This will keep this from rusting or corroding until other grease is forced in there. Then slide the bushing back on and install the shim pack you just made up. Once that's on, place it back into the unit. Once the bolts are snugged up, they'll have to be torqued. Now we'll torque these to 37 foot-pounds. We are now ready to grease the elements and fill the inner part up. Something I should point out on the JSE1 is that this nut that protects a grease fitting on the end of the plunger. On the JSE2, however, the plunger is big enough so that it is recessed and the grease zert is protected by the end of the plunger itself. Now this nut was put on with Loctite, so to get it off and break the Loctite, We'll need to use a small propane torch and heat the nut. Now that we're at this point, we can go ahead and disassemble as we did with the JSE2. Remember, the only difference in the two units is size because they relate to the horsepower. If you have any problems with the procedures we've outlined for you today, be sure to review this program.